Okay, in this video we're going to look at rewriting an equation by eliminating the parameter. We're going to break this part of the section up into a couple videos to make it easier to digest. So in the last video we looked at how to sketch the parametric equation by plugging in values for t, and while that will work, it's not always the most efficient in terms of time in order to graph a parametric equation. So we can eliminate our parameter t by solving one of our equations for t and substituting it into the others. So much like the substitution method for solving systems of equations from prior math courses, we can use that idea to help us eliminate our parameter, which will then allow us to get the equation and hopefully the graph a lot quicker. So example 2, we're going to eliminate the parameter in example 1 and write the equation using only x and y. So once again we have our parametric equations from example 1, and we could solve either one of these for t, and in terms of easiness, the second equation, y equals 2t minus 1, because I won't have to get any roots involved or anything of that nature, be easier, in my opinion at least, to get this t by itself and substitute it in for the equation above it. So with y equals 2t minus 1, we add 1 and then divide both sides by 2. We get our t as y plus 1 over 2. So the value of t is the y coordinate plus 1 divided by 2. And now we can take this expression and substitute it in for this t in this first equation. So with x equals t squared minus 1, we're going to substitute a y plus 1 over 2 in for t and then simplify it. So when we do that, we get x equals y plus 1 over 2 all squared, and then bring down the minus 3. Add 3 to both sides, and on top we'll get y plus 1 squared over 2 squared is 4. And if you want to, you could expand out y plus 1 squared and get y squared plus 2y plus 1 all over 4, but you don't always have to. But if we want to clear out our fractions, we can multiply both sides by 4, and we'll get 4 times x plus 3 equals y plus 1 in parentheses squared. So we have the parabola that we saw in the video in the last, at the end of the last video, described by 4 times x plus 3 equals y plus 1 in parentheses squared. Now, because this describes a parabola that goes to the right, opens up to the right forever, we saw in our graph of our example 1 in the previous video that it did not go up forever, or it went up forever. It could go up forever, but it would not continue to go downwards forever because we restricted our values of t to be greater than or equal to -2. So if t is equal to y plus 1 over 2, we want to guarantee that our y plus 1 over 2 values are still going to be greater than or equal to -2. And this will stop the parabola from opening downward forever, as we saw in the at the end of the previous video. So we multiply both sides by 2 and then subtract 1. We'll get our y values are greater than or equal to -5. And if you look at the graph of x equals t squared minus 3 and y equals 2t minus 1 when t is greater than or equal to -2, all of our y coordinates are at -5 or higher. So our final answer for this example is 4 times x plus 3 equals y plus 1 in parentheses squared, but we're going to restrict this to only include y values that are greater than or equal to -5. So we were able to rewrite the parametric equation using nothing but x's and y's, and then having a restriction on our values of y. Alright, that about does it for this video. In the next video we're going to look at several more examples, so I will see you then.